Hello friends, you are welcome to session 5 of Unit 4. In this session, we are going to determine the nitrogen content in a poultry feed. Let's proceed to look at the objective of the session. By the end of this session, you should be able to determine the nitrogen content in a poultry feed using back titration procedure. Okay, so let's kick it off with this problem. The nitrogen content of a poultry feed can be determined by converting all the nitrogen in the feed to ammonia and then bubbling the ammonia through excess hydrochloric acid. The quantity of HCl remaining is determined with a standard base. D is a solution obtained by bubbling a certain amount of ammonia gas through 100 cubic centimeters of 0.1 molar HCl. E is 0.1 molar sodium hydroxide. Before we proceed, we need a plan. Let's look at how or what is likely or what would happen in this case. For this very solution, we expect a reaction here. We expect a reaction between the hydrochloric acid and the ammonia gas. And so here, some of this concentration will be consumed by the reaction between the HCl and the ammonia. The ammonia is going to consume some of this concentration. So the excess here, or the leftover, is what would react with the sodium hydroxide. What it means is that we are going to pass through sodium hydroxide to find what was left, and we'll subtract what was left from this concentration here, and that is going to give us the concentration of HCl that was consumed by the ammonia. And using this volume, we can convert the consumed concentration into moles. Then we'll use mole ratio to find the corresponding moles of the ammonia gas and proceed from there. The interesting thing is that in most of back titration, you have issues like this where you have to find excess and then go and subtract from what you started from. You may be given initial concentration to subtract from and proceed to convert to moles, or sometimes you may not be given. You first have to find the initial concentration of the pure sample, then proceed from there. That's how usually back titration questions look like. Okay, so we are to perform this exercise, and the questions that follow are to calculate the concentration of HCl in moles per dm cube of the D, and then the moles of HCl that reacted with the ammonia, or the moles that was consumed. Then we'll find the mass of the ammonia that was bubbled through the HCl to prepare D, and then we'll find the percentage mass of nitrogen in the feed, assuming D was obtained from 0.5 grams of the animal feed. So we start from the sodium hydroxide because we know its concentration and volume. The concentration was 0.1 moles per dm cubed. We interpret from there. 1 dm cube is equivalent to 1000 cubic centimeters. So if 1000 centimeters cubed of sodium hydroxide contains 0.1, then that volume that was used, that volume of the sodium hydroxide that was fetched, the 19.50 that was used to react with the acid, will contain 19.5 times 1 over 1000. That gives us 0.00195. So we proceed to look at equation of reaction between the sodium hydroxide and the hydrochloric acid. Okay, take note, it is this volume here, 19.5, that reacted with the small volume of the acid. In our mole ratio, we have 1 mole of sodium hydroxide reacting with 1 mole of HCl. If the mole ratio if the mole ratio is 1:1, then moles of sodium hydroxide is equivalent to moles of hydrochloric acid. Hence, the moles of hydrochloric acid is 0.00195. Good. Now, this number of moles of the acid is the moles in that volume of the acid that reacted with this 19.50 cubic centimeters of the base. So this is not in the 1000 cubic centimeters, but rather the 25 cubic centimeters that was actually used. So if 25 contains this 0.002 mole, then 1000 will contain what? We have this relation and it gives us 0.078. Another way you can do this is, once you know the moles, you just have to convert this volume into dm cubed, and when you convert, you use your relation C is equal to N over V. So your N, which is the mole, is here. The volume, which is thus converted into dm cubed, it will give you the same answer. So this is the excess or the leftover. After the ammonia had taken some away, this is what was left. So this is the excess. To know what the ammonia took out of the hydrochloric acid, we need to subtract this excess from the initial, which is 0.1 that was given, and that gives us 0.022 mole per cubic decimeters. So this is the concentration of HCl that was consumed. If we know this, then we also know the volume of the HCl that was treated with the ammonia, so we can use in conjunction with this to get the moles that was consumed. We know that moles is equal to concentration times volume. So moles of HCl consumed is equal to concentration of HCl consumed times volume of the HCl that was used to prepare that solution. And so we have 0.022 times 0.1. It was 100 cubic centimeters that was used. So when you convert 100 into decimeters cubed, you have 0.1. And that gives us this 0.0022 moles. So this is the moles of the acid that was consumed. From here, the way is always that we would now write an equation of reaction to find the corresponding moles. So we now know of the HCl. So through that path, we are entering into the ammonia, but we need an equation of reaction. This is the balanced equation of reaction. And from this balanced equation of reaction, 1 mole of the ammonia reacted with 1 mole of the HCl. If this is the relation, then it means that the moles of ammonia is equivalent to the moles of the HCl, and in this case the moles that was consumed. Since the moles of HCl is 0.0022 moles, it means the moles of ammonia is also 0.0022 because the mole ratio is 1:1. Knowing the moles, we can proceed to find mass, but we will need the moles and molar mass. So we find the molar mass of ammonia, that is 17 grams per mole. And from the relation, mass is equal to amount in moles times molar mass, that is N is equal to mass over molar mass. We make mass the subject. So we go for our moles of the ammonia here, and then we go for the molar mass in place of the molar mass. Now when you multiply this, we have 0.0374 grams. So this is the mass of the ammonia that was bubbled through the gas. But the last question is to find the percentage by mass of nitrogen in the feed. And before we can do that, we first have to find the mass of nitrogen in the feed. In doing that, the molar mass of ammonia would be of great help to us. We know that The molar mass of ammonia is 17 grams per mole. That is, we have 17 grams in 1 mole. So if this 17 grams of the ammonia contains 14 grams of nitrogen, then that 0.0374 grams of the ammonia that we have calculated will contain how many grams of the nitrogen? So if 17 is equal to 14, then 0.0374 is equal to x. We find the value of x, and that gives us 0.03 grams of the nitrogen. So this is the mass of the nitrogen in the feed. Given that the total mass that was used was 0.5, then we can find the percentage by mass by dividing the mass of the nitrogen by the total mass and then multiply by 100. That gives us 6%. So this is the percentage by mass of nitrogen in the feed. We are ending the session with this self-assessment question. Please try it. We'll meet again in the next session.